So we have an array of structs and a struct of arrays. Which one is faster? Well, it depends on how you use or access the members. The main difference between them being how they are represented in memory, which may affect how efficient the CPU can use its cache. Let's say that we're going to primarily access the elements through the ID. So let's print the amount of unused distance between the IDs. For array of structs, it's 8 bytes because we have two integers and each struct is contiguous, whereas for struct of arrays, if we print it, we have 0 because the arrays or each element is contiguous to the next element. Why does that matter? Well, let's look at how they're represented first. Again, for array of structs, each struct is contiguous, so to get to the next element of ID, we have to skip 8 bytes. Whereas for struct of arrays, each ID element is next to each other. Now, why does it matter? Well, let's look at how malloc works. To make it fast for small allocations, it avoids the expensive operation, which is the request to the operating system, by requesting a big chunk to the operating system and then putting that into the free list. Then multiple small allocations will just have to traverse the free list if it's not empty. In the same way, loading from main memory or RAM is slow. So when we access this element, which is represented in memory like this, instead of loading one element at a time, the CPU will load a chunk of it to the CPU cache. When we first load the first element, is a cache miss because it's not in the CPU cache, so we load from memory. And for the second element, which is here, we have a cache hit because the element is already in cache. For the next element, we have another cache miss. For the next element, we have a cache hit. For struct of arrays, we have a cache miss. And then for the next 5 elements, we have a cache hit or cache hits. And for the next element, because it's not in cache, we have a cache miss. And then for the next 5 elements, we have cache hits. So if we count here, we can load 4 IDs with 2 cache misses for array of structs, whereas for struct of arrays, we can load 4 IDs with only 1 cache miss. With the same amount of cache misses, we can get 12 loads. If we look at how much of the cache is used, for array of structs, we have 33% actually used. The rest is for the other members which are currently not used. And for struct of arrays, we have 100%, since the element is next to each other. So does that mean that struct of arrays is faster? Well, again, it depends on how you're accessing the struct. For array of structs, the struct is contiguous, whereas for struct of arrays, the members are contiguous. For our example, where we are primarily accessing the ID, the struct of arrays is more cache-friendly in terms of cache locality. For a practical example of how CPU cache affects performance, we have 5800X3D, which gets more FPS than the 5800X with lower clock speed but more cache.